Today, let's go over a medium question that I solved by myself yesterday. I was actually sick yesterday, so the video was low audio, so I'm going to redo it. So this one's called Permutations 3, and it should be a precursor to a Grind 75 question. So let's go over it. So you're given an integer n, and you want to basically generate all rearrangements or permutations of the integer such that no two adjacent elements are the same parity. So what that means is 2 can't be even, and 3, if this is even and this is even, that's bad. If this is even, that's bad. And so the idea here is to generate all permutations from 1 up to this number inclusive, and then also to evaluate at each step whether we have this violation going on. So you can see we're going to return a matrix of integers. So let's define a result. And then now let's use the permutations module in Python to generate all the permutations. So let's say for a in permutations, well, first we need to define our options, which is going to be a list of range from 1 to n plus 1 inclusive, because Python goes up to not including this number. And then we're going to generate the permutations of this. Okay, and then let's print our permutations to see. So cool, this looks like it matches up, except now we have to filter. So as we said, let's start from the first and go up to including the second to last element. And let's say if for I in range 1 to length of a minus 1, so we're iterating over this tuple right now. So if the current number is even and the previous number was even, then we have a problem. So let's have a Boolean flag, and we can set that to false. And then we can break right there because we already know that this is not going to be one of the answers as a list. So let's do the same for the previous element. For odds, or modulo 2 is not equal to 0, then flag equals to false and break. So we're comparing the current to the previous, and then now let's do the same thing except with the current and the one to the right. So let's do this. We can just copy this even, and then do not equal to 0. Actually, let's write this out by ourselves. So if a of I modulo 2 is equal to 0 and the one to the right, so a plus 1 modulo 2 is equal to 0, then we have a problem, right? So then we can false and break. And we're not going to go out of bounds because we went to up to not including minus 1. So, and lastly, let's do odd check to the right. False and break. Break just makes it faster because we don't have to keep checking once we find some kind of a violation, right? And then at the end, if flag is still true, there were no violations. So let's print A. Let's get rid of this print. And now we can just append a list version of this tuple because permutations generates a tuple. And then we can append result once we're done. We generated all the permutations. And there you go. So it beats 100%. This question just came out yesterday. I solved it by myself when I was sick, and the audio was pretty low again. So just wanted to redo this video, as you can see. So yeah, hopefully this is helpful. It's a pretty straightforward question, and thank you for watching.